Hi there. This is going to be the first video for the series Geometry and Nearest Neighbors. And in this video, we are going to discuss about the geometric view of data. When we were studying decision trees, we have learned that prediction tasks are simply mapping inputs to outputs. Given an input x, we map them to an output y. We have also learned that decomposing an input into a collection of features forms a useful abstraction for learning. In here, we see that input x is decomposed into 4 features. Well, we can actually have any number of features, but in this example, let's assume that we only have 4 features. So if we have an n number of inputs, we can see here that inputs are just lists of feature values. Taking a particular input and output pair or an xy pair, and if you think of each feature value as one dimension, so let us say x feet 1, x feet 2, x feet 3, and x feet 4. Each of these feature values are dimensions. So if they are dimensions, then we can simply treat an input as a vector mapped to a particular output y. In short, an example is just a point in a high-dimensional space. This suggests that we can achieve a geometric view of data. So once we think of a data set as a collection of points in a high-dimensional space, we can start performing geometric operations on the data. For instance, suppose you need to predict whether Alice will like algorithms. Perhaps what we can do is to find another student, say for example Jeremy, who is most similar to Alice in terms of favorite courses. If Jeremy liked algorithms, then we might guess that Alice will like algorithms as well. This is an example of a nearest neighbor model of learning, and it's made possible when we look at the geometric view of data. And that concludes the first video of the series Geometry and Nearest Neighbors. See you in the next one.